Uh, these notes are on a continuation of right triangle trigonometric ratios. So in the first set of problems we saw in the previous notes, we looked at just setting up the ratios. In this problem, we're given one of the ratios, sine A, and we're asked to sketch the triangle and find the possible values for the missing side. Then to find the other missing trig ratios for both angles A and B, where angle C is the right angle. So the first thing I need to do is I need to remind myself that sine A, that the sine ratio is opposite over hypotenuse, which means that my opposite length is square root of 3 and my hypotenuse length is root 2. I'm going to sketch my triangle. I'm going to have this one be A, B, C. So opposite from A is root 3, and hypotenuse is 2. Now remember, because these are ratios, these values could all be multiplied by any number. They could be multiplied by 10 or by a half or by 2, but when we're writing the ratios, they reduce to these values. So it doesn't matter if I stick a 10 in front of the square root of 3 and multiply 2 by 20. Once I write the ratios, they will all reduce down to the same thing, regardless of the multiplier you've used. So to simplify things, I'm not going to use a multiplier. So now, in order to finish this triangle, I need to find the side length AC. So you'll remember that I have in my pocket always, when I'm looking at right triangles, the Pythagorean theorem. And so I have leg 1 squared plus leg 2 squared equals hypotenuse squared. So in this case, they give me the hypotenuse and one of the legs. So I'll leave this one as the one I don't know, leg 1 squared. And leg 2 we said was square root of 3, and the hypotenuse is 2. So I have leg 1 squared plus 3 equals 4. Leg 1 squared equals 1, so leg 1 equals 1. So now I'm just going to add that into my picture, because now I'm going to write the remaining trig ratios. So I'll do cosine A, which you'll remember is adjacent over hypotenuse. So from A, the adjacent is 1. And the hypotenuse is 2. I'll then do tan of A. Tan A is opposite over adjacent. From A, the opposite is root 3. Over the adjacent is 1. So that simplifies to be root 3. And then if you'll remember, you can do this one of two ways. You can remember that sine of B equals cosine of A, so that's going to be 1/2. Or you can remember that sine of B is going to be opposite over hypotenuse, but from angle B. So opposite is 1 over hypotenuse 2. The same thing is true of cosine B. Cosine B equals sine A, which sine A is root 3 over 2. But if you don't remember that, you can always go back to the fact that cosine B is going to be the adjacent over the hypotenuse, and from angle B, adjacent is root 3 over hypotenuse 2. Lastly, I have tan of B. And again, if you remember, tan of B is the reciprocal, so 1 over tan of A. So that's going to be the reciprocal of this, so 1 over root 3. And mathematical nicety tells us that we can't have our square root in the denominator. So to get rid of that, I multiply the top and the bottom by a fancy looking 1, root 3 over root 3, which gets me square root of 3 over 3. And if you don't remember that the relationship between tan B and tan A, you can go back to the opposite over adjacent. And so from B, opposite is 1 over adjacent is root 3. And again, that same process of getting rid of the square root in the denominator. So I'm just going to highlight the fact that this is 2 ways to find sine B, 2 ways to find cosine B, and 2 ways to find tan B. And either way will get you the right answer. It really is up to you in which case, which one you're the most comfortable with. So just to summarize, these are some of the trig identities that we just used. We use the fact that sine A equals cosine B, and cosine A equals sine B. That was one of the relationships that we just used. And again, if it's not a relationship that you remember, that's not a big deal. The other one that we used was tan A equals 1 over tan B. Now, 2 others that you discovered, proved are true in class was tan A equals sine A over cosine A, and sine squared A plus cosine squared A equals